whenever I'm giving a talk at Linköping University, they always measure the biggest success by the number of people that stay after the break. I think I just failed. Oh, there you go. Actually, my record around there is actually I got 4 more after the break than I had before the break. That was pretty good. Well, let's go on anyway. Java is boring. There you have it. That's the reason why Java won't live on for 10 more years. Java is boring. And now you're thinking, is he going anywhere with this, or is he just being mad? Or I mean, I'm a Sun guy. I'm a Java architect at Sun. I should love the technology, shouldn't I? I do. It's still boring though. There we go. They didn't play it anyway. So, the reason I'm saying this is, what, do you agree? How many of you agree that Java is boring? Not very many. I love that. Fools. Anyway. The thing is, Java, how many of you tried Ruby? Ruby? No. Ruby. Well, how many of you have tried Ruby? You like it?
Yeah.
It's fun, isn't it? How many of you tried Python? More. It's fun, isn't it? Groovy? Groovy? Well, that's you. You tried Groovy. Lisp? Yeah. And that's really fun, isn't it? That's sort of the most awesome, the awesomest. It's a language built out of pure awesome. That's what Lisp is. Pascal. Yeah, whatever. So all those languages. Why do we like those languages? Because they're fun for programming, right? They're really fun. There's a lot of stuff that you can do in them. They're expressive. Their sort of syntax and expressiveness makes terse programs, and it's you get to do a lot of really fun stuff and use things like closures and stuff that we just don't have in the Java language. Because Java, Java, when it comes down to it, is just another imperative, third-generation, object-oriented language. It's not C on steroids, it's C++, which also makes it sort of even less fun. Because when I started programming, when I started programming professionally, not when I started programming because that was in BASIC, like several decades ago. But when I started out programming professionally, I started out in C. And we had, I think, we supported 3 platforms, 3 different brands of Unix. Sun OS, HPUX 7 and HPUX 8. And more than 60% of our code was actually cross-platform code. Which I can tell you makes for a very interesting programming experience. Cross-platform programming in C, and I mean, remember, this was 3 different versions of Unix, and the reason for 3 different versions is that, of course, HPUX 7 and HPUX 8 wasn't really compatible for some reason that sort of defies understanding. So this was 3 different brands of Unix, and we still have more than 60% cross-platform code. Code. And of course, that couple. How many of you programmed C? All of you. Brilliant. So then you know that chasing pointers and doing all that stuff, and memory leaks and all that stuff also makes for a very interesting, as in the old Chinese curse, may you live in interesting times, kind of programming experience. Because it is interesting, and we did amazing stuff with C and X Windows libraries and things, and it was pure fun, even though we didn't get to sleep that much, because we spent our nights, as I said, chasing shot pointers and memory leaks. But We did amazing stuff. And then we started tried our hands at object-oriented programming. We started out trying C++, but C++ wasn't fun back in 1993. The only compilers you could actually buy that worked or get that worked was horribly expensive, and GCC did do C++ that worked. So we did that, and then we found Java, and well, actually I found Java because no one else bothered at the time. But I found Java, and I thought, oh, this is right. This is object-oriented programming as it should be, 1995, and it actually was. It was object-oriented programming as it should be. Never mind that Python actually been around for 6 years back then, but I didn't know Python, so and no one else did either. And it was fun. Even though I sort of missed the pointers, and I thought I probably need a macro facility at some point, or a preprocessor of some sort, as C had. But then again, I could live with that. And more and more, I learned the Java idiom of programming, and I understood why I shouldn't have multiple inheritance and things like that sort of drive. And it was still fun because I actually got the job done. But the programming part was sort of less and less exciting because, well, the programming part for me consisted very much of actually trying to convince the platform that I had to do whatever I wanted it to do and find all those weird bugs and all that stuff. And I just didn't have that with Java. So going forward a couple of years, a couple of new languages entered the stage, like Ruby. Python re-enters the stage, or re-emerges from the depth of history, and a lot of other stuff. And suddenly, I can do a lot of fun stuff with the program. I can do a lot of fun stuff with my languages, passing closures around, having higher order functions, and a lot of stuff like that. And suddenly Java is sort of non-expressive and non-creative. And that's exactly the problem we have. Because what is a problem with non-creative programmers? Because programming, as you would, I'm sure you would agree, is a creative process, right? Yeah. Because through programming we express the little creativity we actually have as engineers. I mean, we're not that creative from the beginning, but I mean, we can do it at least with programming. And having languages that sort of support this creativity, like Lisp, like Ruby, like Python, like Scala. You should try that. I mean, you should try Scala. Or you should try it. It's a fun language. It's packed with everything but the kitchen sink, but it's really, really fun. And compared to those languages, suddenly Java is boring, and that's why I say Java is boring. So we have all these languages, and we have all these languages that are sort of more fun to program in than Java is. And on the Java platform, we're sort of stuck with Java. But also because, I mean, I'm talking about this because there is no one language to rule them all. If there were one language, if everything was sort of down to, well, we only need one language, then it would probably be in assembly, right? And not Java or C or C++ or something like that, because every language has something that makes it more suitable and more useful for a particular purpose than other languages. There's a reason behind every language, even though the reason might be just that it's the world's hardest language to write in. There is actually a language like that. Look it up. I can't pronounce its name, but that's why I won't tell you what it is. It's a weird language. It's named after one of the layers of hell in Dante's Inferno. So every language, there's a reason for every language. And I think you'd agree as engineers that one of the keys to successful engineering is using the right tools for the job and not falling into the golden hammer anti-pattern trap. That is, if the only tool you have is a hammer, then all problems tend to look like nails, right? So, having all that, why do we insist that we write in one language? And I actually meet customers of mine, CIOs, no, not CIOs, but IT managers, chief technology officers and stuff, and people like that, that say, we're now standardized around Java, and we will write all our applications in Java from here on. And of course, I have to say, good for you. Well done, because I'm from Sun. But of course, what I want to say is, why on earth would you want to do that? Why on earth would you want to punish your engineers so severely that you condemn them to a life of only one language? Because in reality, of course, we're writing several languages. Even in a real Java application, in a standard Java application project, we're writing several languages. How many do you think? Or which languages do we write in? C. No, not C. Not in a Java application. We don't write in C in Java applications. Java is one of them. XML. HTML, yes. JSPs. And scripts, which is sort of like XML, but it's something else, right? Because there's still things we need to learn about it. And so forth. JavaScript. And so forth. And we have several languages, and we don't reflect about on that, but CTOs and people like that still insist on that we write everything in Java, because we don't. And right, completely lost my chain of thought here. Yeah, right. So, and this is some sort of weird artifact from the 90s, where suddenly the entire industry, because looking back at the 80s and further back, we all wrote in a lot of different languages. Pascal for the DOS platform, or C for the DOS platform, C for Unix. We had a lot of Unix utilities that had their own languages like AWK or Awk. And we had make files and a lot of stuff like that. We wrote in Fortran, we wrote in COBOL, we wrote in Smalltalk, we wrote in a lot of languages. But suddenly during the 90s, we thought as an industry, nah, let's not talk about this programming language stuff anymore. Well, it will all go away anyway. So we will have program generators that just sort of think to it or speak to it and say, computer, write me a program that's, well, and so forth. And suddenly we all thought, well, we only need one language. Of course, we can never sort of really, we could never sort of really well, there was a lot of different views which languages was. Was it C, C++, Java, and later on C#, or what was the language? But we all knew that was just one language that we needed to use. And of course, fortunately, this is now all changing. I don't know if you've heard it, but there is definitely a programming language renaissance going on. There's a lot of new languages coming up, and a lot of sort of actually rather large players like Microsoft and IBM is doing a lot of language research and coming up with new languages. Because of course, as I say here, there's sort of languages are the means by which we are certified as programming artists, and the languages are tools. Our programming languages is our tools. Even though the programming languages might be graphical UML editors, that's still a programming language. It will generate running programs for it, from it. So this is something that this is our chief tools. This is what we use for expressing our solutions to the problems that we're facing as programmers or as engineers. So having that, having to use only one language seems sort of rather silly. So, looking at things that we like with the Java language, sort of positioning Java and the Java platform and all this. What is the things that we like in the Java language? Well, one thing, of course, automatic memory management, garbage collections. And if you're written in C, which you all have, then you know that this is actually a godsend. This is the best thing. I think the greatest gift to mankind is garbage collectors that work. That is. Also, strong typing. Object orientation. Someone said object orientation is a reason for liking Java, and it is a very good paradigm, certainly. No pointers. I can reason about that, but speaking as a professional C programmer, I say no pointers is a really good thing for meeting your deadlines and writing stuff that actually works. Write once, run anywhere. Brilliant. As I said, that's how I started out my Java programming career. Runtime optimization. There's a lot of stuff that we can do in runtime that you just can't do in compile time. Rich class libraries, and we've been through all this, right? These are the reasons why you like Java. Rich class libraries, we have the best class libraries on the planet. Static typing, well, if you're into Ruby and dynamically typed languages, maybe you don't agree with this, but I can say that I've learned a lot from static typing. I was a sort of more a COBOL programmer back in my C days, because C is fundamentally an untyped language. For any real C application, you'll end up with pointers and, well, structs or memory areas. So C is an untyped language. And it's simple, clean, and expressive, compared to C++. All right, so that is the Java language and the reason that we like Java. But apart from the two last ones, none of those are actually properties of the Java language itself. Those are properties of the Java platform. It's the Java platform that gives us things like automatic memory management and strong typing, object orientation, no pointers, write once, run anywhere, runtime optimization, rich class libraries. That's the Java platform. It has nothing to do with Java language. So, wouldn't it be cool if we could have all that, but still write in another more expressive and fun language? There we can. This is a site, a German professor called Robert Tolstorff. He collects languages that runs on the JVM. This is the URL. Go have a look. It's really fun. And last time I looked through it, which was actually over a year ago, there are 203 languages there. So there are 203, or there are more than 200 different languages that you can use to write Java programs. Because fundamentally, I don't think that it really matters in which language I write my program as long as it runs on the JVM. And as long as I have my fellow programmers know the language as well. So having this enables us to actually to be able to choose the language that is right for the job and write our program in that. This is Robert Tolstoy's categories, by the way, not mine. It's fun. These are the different number of different languages in each category. We have 21 different lists for the three of you that list. It's fun. We have 11 basics. Who would imagine that? What we even have a COBOL, by the way. And that's the fun part with that is that it's actually commercial COBOL. So there's a company that sort of sells and makes money from selling a COBOL for Java, which is really weird, I think. I usually say that my greatest surprise with this list is that there are 21 Lisps, and Tobias Riekster, who used to be a teacher and still is in some respect, and will be back as well. He says that his greatest surprise is that Iphone is its own category. Oh, there you go. And there are even 4 assemblers. You can actually write assembly programs for Java. Sort of writing in bytecode directly, but in a bytecode assembly program, which is fun. Right. So, if we have this, how can we use it? And this is how we use it. Because, how many of you have heard about the scripting support in Java 6? Only a few. Now you heard about it. In Java 6, I think that this is, there's a lot of new stuff coming in Java 7, and if we'll have time, I will try to talk about that as well. But in Java 6, the thing is, Java, every odd number of Java is a feature release. A lot of new features get added, and every even number of Java is a maintenance release, just sort of better performance and better everything that's already there. But in Java 6, they added the Java scripting support, or the scripting framework for Java, or JSR 223. As it was called back then. The actual JSR was called. And I think that this is probably one of the most important features to be added to Java since, well, Java 2, I think. And the reason for that is that it opened up the doors. I mean, we already had the 200 languages, but was actually before Java 6. So this is not a feature of suddenly having a scripting framework. People have been writing languages for the Java platform or for the JVM for 10 years now. But in Java 6 and the Java scripting support, we suddenly have unified scripting support for the Java platform, which means that Java languages that run on the JVM can actually do stuff with the other, and we can actually use them. So it started out as JSR 223, or it actually started out as something something that was supposed to be able to allow us to generate web content. That is, it started out as a project for making PHP run on the JVM, because there's a lot of web applications in PHP, and web applications are a huge market for Java. So therefore, we wanted PHP on the Java. But it sort of ended up as a generic standardized scripting API. So we have 3 technologies, whereas 2 are really, really important. First of all, we have a general scripting API, which is just allows us a unified way of calling scripts or programs in other languages from the JVM or from the Java language. And then we have language bindings, which means that we can bind variables in these script engines to variables or to data in the JVM. And this is what it looks like. Calling a script is really, really easy. First of all, you need to get a script engine manager, which is just new scripting engine manager. And then you want a script engine for this, for instance, in this case, Ruby. And you manage a get engine by name, and when you instantiate the script engine, it will find all the script engines using the plugin support. It will find all the script engines that you have in your class path. So we can find a Ruby script engine if we have a Ruby script engine in our class path, and then we can start evaluating scripts like this. Or we can do it from a general reader, so we can just read a file and use it. And we can also get script engine by extension. For instance, if we don't know what the script is actually, which language the script is written in, but we know the extension, or we can do it from a MIME type. And we can also get a list of all the script engines that we have, so we know which languages we're supporting at the moment. So let's have a look at this. There we go. This is a test application that I wrote. Because when the script engine framework was released, the script engine engineering, they had a demo application which was a desktop calculator with 4 scriptable soft buttons on it, so which you could write scripts in JavaScript. Because a JavaScript engine is actually included in Java 6. So that's something you can use out of the box. But I thought that it was lame. So let's do something a little bit more interesting. So I created this scriptable calculator which actually has 32 scriptable buttons, and that's all it has. It also has a display and a stack and an input register, which is basically just a string. Well, not only basically, it is a string. So at the moment it can't actually do anything apart from rendering the content of the stack on the display. But as it's running right now, the stack is empty, so we have nothing to render. So let's start writing a calculator. To do that, we need to create a new script. Can you all see this? No, I'm afraid you can't. So let's do it like this. So let's see. So in order to, the first thing we need to do to have a calculator, of course, is being able to enter digits. So, as I said, we have an input register. So, for instance, which is a string. So, for instance, if we want to enter ones to the input register, well, just concatenate the string 1, which would enable us to sort of build up a value using that. And let's see what language. Here are all the languages that I have in my class path at the moment. So let's use Python. And we need to bind the name input to the input register to a name. So that's where what we have here. And I need this facility because every language has different rules for what the variable may be called. For instance, if you have a program prologue, you know that variables need to start with a capital letter, for instance. So we don't have a stack, we don't have anything else. Let's just call it 1.